When you flip a coin up in the air, what do you think it is while it's flipping? Heads? Tails? Or a little bit of both? It's like asking if the light in the fridge really goes off when you close the door, right? Now, quantum physics is that wacky place where magic meets science, and illusions aren't just for magic shows anymore. The universe we can see is already weird enough, but there's a whole other half that's just theoretical, yet somehow real. And it's even weirder. And believe it or not, some cat stuck in a box has actually helped us figure out more about this brain-twisting science. Sounds nuts, right? Kinda like finding out about gravity because an apple decided to play a game of Bonk the Scientist. Imagine a cat that's both a zombie and alive at the same time. Welcome to quantum physics, where sometimes the rules make more sense in a wizard's handbook. And apparently, cats have pawed their way into being physics professors. So how exactly did a cat caught between life and death shake up the world of quantum physics? Hats off to Erwin Schrödinger for the head scratcher. This Austrian physicist popped into the world in 1887, a time when science hadn't even proven that Frankenstein's monster wasn't going to jump off the book pages. If biology was still scratching its head over horror fiction, you can bet quantum physics was still back in the Stone Age. Back then, physicists could barely agree on the basics of quantum stuff. You had Team Niels Bohr, believing the quantum world was as random as a lottery draw. And then there were the folks convinced it was more sorted than a librarian's bookshelf. And Schrödinger? He wasn't buying the whole universe on a whim theory. The science world was like a big family dinner, where no one can agree on what pizza topping to get. Schrödinger spent his days figuring out how electrons do their dance, sometimes acting one way, sometimes another, or just being all mysterious and doing both. This funky dance move was called quantum superposition, and believe it or not, a cat was his go-to example for explaining this mind-bender. And it wasn't just Schrödinger questioning this whole dual existence vibe in quantum science. Even Einstein was in on the action, penning letters to Schrödinger now and then, worried that quantum mechanics was still a book with half its pages blank. These two weren't just exchanging pleasantries, but deep, science-y thoughts. While most folks were writing mushy love letters, Einstein and Schrödinger were nerding out in their own little bromance over particles and probabilities. Let's just say, having Einstein in your corner on anything science-related, yeah, you're probably onto something big. Before you start thinking Schrödinger was some sort of mad scientist with a hate against cats, let's set the record straight. No real cats were ever used in his famous experiment. It was all just a brain game, a hypothetical scenario with a fictional cat in the starring role. So, chill. No cats were put in jeopardy. Schrödinger liked cats too much to ever stuff one in a box with something as nasty as radioactive material. Unless, maybe the whole universe was on the line. Here's how the imaginary experiment went down. A cat placed in a sealed box that you can't see into, chilling with a bit of radioactive material. This stuff has a flip-a-coin chance of decaying within an hour and zapping the cat. And no, this wasn't a diabolical device from an episode of Tom and Jerry. This was straight out of a scientist's imagination. With the box still closed, you can't know the fate of the cat, if it was dead or alive. The radioactive atom either decayed, becoming poisonous to kill the cat, or it didn't. And it's not possible to know if the cat is dead or alive until you open the box. And that's the whole point of this brain teaser. If you can't see the cat, there's no way to pin down what state it's in. So, while it sounds a bit bonkers, you could argue that the cat is both dead and alive until you check. Only when you take a look does one possibility drop out, leaving behind the cold, hard truth. And that's exactly what Schrödinger was trying to show everyone. The idea was that the outcome or state of something isn't set in stone until someone actually checks it out. Until you take a look, every possibility is out there, doing its thing all at once. Now, as nutty as this sounds, it's not really meant for everyday stuff. Like, don't try this with your morning coffee to see if it'll turn into a cappuccino. This whole brain bender was all about the weird world of quantum mechanics, a place so strange you can't just eyeball it. Back when Schrödinger was playing with this concept, the big thing in science was the Copenhagen interpretation of quantum mechanics. Everyone was cool with the idea that electrons were both waves and particles, and light was doing its dual thing too. But when Schrödinger's cat waltzed in and threw a curveball, showing that all these theories hold up, right up until someone actually checks to see what's going on. It really spotlighted how crucial the observer is when you're dealing with events that can go one way or another. Man, Schrödinger really threw a wrench in the works for a lot of scientists. To pull that off, you need a hefty dose of smarts and guts. Using a cat to explain what happens to atoms and subatomic particles might not be exactly spot on. It's like comparing apples to invisibly small apples. But hey, it does show that the rules of the quantum world don't always play nice with the regular laws of physics. And while it kinda put the lid on some wild guesses about superpositions, it definitely kicked open the door for a whole bunch of new interpretations. Niels Bohr, who wasn't exactly a fan of Schrödinger's cat experiment, either really believed in his Copenhagen interpretation or was just too stubborn to admit he might be wrong. The typical stubborn scientist vibe. Bohr stuck to his guns, believing that the observer didn't really affect what happened to the cat. While some folks were busy trying to poke holes in Schrödinger's ideas, others, like John von Neumann, were ready to push it even further. He said that while superposition lets things exist in multiple states, one thing you can't have in superposition is the conscious observer. Okay, take a deep breath, because the next part is a brainful. Basically, if an observer checks on the cat but doesn't spill the beans, then, as far as anyone else knows, the cat's fate is still up in the air. To the outside world, the whole cat situation remains a mystery. And believe it or not, these are some of the simpler takes on this experiment. In 1957, scientist Hugh Everett threw his own twist into Schrödinger's cat saga. And honestly, his idea sounds more like a pitch for a sci-fi movie than a legit scientific theory. But hey, sometimes life, and apparently science, really does seem to mimic art. So basically he said that even when an observation has been made, let's say the cat was observed to be dead, there is still the existence of the other outcome, the cat being alive, just that it's in a decoherent reality. One alternate and not part of the one where the initial inference was made. And those are just a few of the twists on the tale over the years. There's a whole lineup of interpretations, like the ensemble interpretation, the transactional interpretation, and a bunch more. While everyone was busy giving their 2 cents on the Schrödinger's cat experiment, it was quietly revolutionizing not just quantum physics, but other fields too. Thanks to pondering over a cat that's both dead and alive, we've seen big leaps in quantum computing. Turns out Schrödinger's musings helped advance the superposition of qubits, the basic building blocks of quantum computers. It has gotten a boost because Schrödinger wondered about a cat in limbo. Wild, right? But that's not the only tech that's gotten a leg up. Sensors now use technology based on superposition to measure stuff like magnetic fields and gravity. These gadgets are now staples in medical imaging tech like CT scans and ultrasounds. Honestly, there isn't a corner of tech that hasn't felt Schrödinger's influence, all thanks to his brain-bending experiment with superpositions. The man's practically an unsung hero. Maybe he doesn't get as much hype as other scientists because his work was super abstract, but he proved you don't always need fancy equipment for groundbreaking scientific experiments. Sometimes, the best thing you can do for science is just sit down and think. And it really makes you wonder, if he absolutely had to, would Schrödinger have actually used a real cat for science? Let's hope not. Curiosity might not have killed Schrödinger's cat, since the cat was never real to begin with. But it sure did a number on the old school belief that an observer's viewpoint doesn't completely change what's going on with quantum superposition. Using just a make-believe cat in a thought experiment, Schrödinger managed to show everyone that perception isn't just important, it's everything in the quantum realm. This idea didn't just shake up the usual way of thinking back then, it opened the door for future quantum physicists to look at and measure the weird and wacky quantum world in a whole new way. So, what do you think? If you had a cat, would you let it play a starring role in a quantum physics experiment? Just kidding. Please don't use real cats in science experiments. If you found this dive into quantum quirks as intriguing as a cat with 9 lives, don't forget to hit that like button, subscribe for more mind-bending science stuff, and share this video to help spread the quantum weirdness even further.